Okay, hello everyone. My name is Mingshen from security team in Baidu. So today on behalf of the Teaclave community, I will talk about the open source universal secure computing platform, Teaclave. I will start with background and then briefly introduce current status and some highlights of Teaclave projects. Then I will provide some details of Teaclave internals. And last, I will talk about how to get involved and also present you the Teaclave community. Okay, let's get started. So I think as we all know, because we are in this conference, the emerging technology of big data analytics, machine learning, cloud edge computing, blockchain, and other technology, they want to use a public cloud infrastructure. But they are also bring new confidentiality and security issues, and also the intellectual property, such as models and algorithms, is also a problem we need to consider if we put that on the public cloud. So, as illustrated in these figures, confidential computing provides a solution for trusted and secure execution environment that define the big data business model. For example, the financial data, health data, security key AI model, big data analytics, blockchain, they all can all be done on the trusted execution environment to ensure the confidentiality and integrity of the data and business logic. This secure computing, or someone call it confidential computing, is to provide a safe place for multi-party to compute the sensitive data. So, for example, they can compute private site intersection, private machine learning, some technology like homomorphic encryption, oblivious transfer, or MPC. And others may want to use hardware-based isolation like memory encryption and attestation. For example, Intel Sgx, ARM Trust Zone are most popular to the implementations. Currently there are a lot of platform providers like Microsoft Azure, Google Cloud, and IBM Cloud. So normally for Intel Sgx, for this TE implementation, they split application into two parts: a untrusted part in the normal world in ARM's term, and the trusted part of secure world. Today I only focus on the Sgx implementation. Now we can use Sgx SDK from Intel to build Sgx application, or from our Rust Sgx SDK to split the legacy application into app and enclave parts for Sgx environment. Or we can deploy legacy app in containerized Sgx environment. For example, the libOS and the unikernel based framework. However, there are still a lot of effort for programmer to develop an Sgx application. For example, developers need to know how to protect data, how to do remote attestation in the right way, how to save data into a platform with a specific CPU, and how to design like interface between untrusted world and trusted world without leaking any sensitive data inside the enclave. So there's still a lot of effort for developers to learn and develop a proper application. So we need a framework to our platform that allow programmers to concentrate on business logic and automate more protection of their code and data without worrying about technical details of Sgx development model. Excuse me, and and different TE implementation. So programmers or user only need to know focus on sensitive data, business logic, and interface between users and the platform. So we want to create this kind of bridge between the concept of TE and the concept of function as service. So we create a platform called Teaclave, and the platform will help to manage the data and execute the business logic in TE. We call it computing unit. It can be deployed as a distributed system on many Sgx machines or other DE implementations, and we create management services, storage services to help to manage all the data flow and functions between the services. So this is the main motivation of creating the Teaclave function as service platform project. So let me give you an overview of Teaclave. Teaclave, or Apache Teaclave, is an open source universal secure compute platform which makes computation on security, privacy sensitive data safe and simple. So this project is originally developed at Baidu, as known as MasterT. MasterT was open sourced in July 2019. Then we donated MasterT along with Rust Sgx SDK to Apache Software Foundation in August 2019. And changed the project name to Teaclave. And also in this year, March, actually this month, we also donated Rust OPTE Trust Zone SDK to Apache Software Foundation as a sub-project of Teaclave. So, so currently Teaclave is under Apache Incubator and open source in the Apache way. So we have 3 main projects right now. One is Teaclave, also Teaclave function as service platform, and Sgx SDK and Trust Zone SDK. So today I will focus on the function as service platform. So let's see some highlights. So first, we provide the function as service interfaces and with many built-in functions like private machine learning algorithm, private set intersection, crypto computation examples. So in addition to these built-in functions, developers can also deploy and execute Python scripts in Teaclave. So unlike traditional function as service platform, Teaclave supports both general secure computing tasks like function as service, and then we also provide a flexible multi-party secure computation interface on top of the function as service interface. So for security, we adopt multiple technology. In particular, we use Intel Sgx to serve the most security sensitive tasks with hardware isolation, memory encryption, and attestation. Also, Teaclave is written in Rust to prevent memory safety issues. And I think later, after we transfer the Trust Zone SDK into Teaclave, we will use Trust Zone in the future to implement some services in other TE implementations. So for usability, we build the components in containers, and you can deploy it locally and within cloud infrastructure. We also provide some convenient endpoint APIs, client SDKs, and the command line tools. Actually, we have a tutorial to guide you through to deploy Teaclave on Microsoft Azure Confidential Compute VMs. And last, modularity. Components in Teaclave are designed in modular, and some components like remote test station can be easily embedded in other projects. In addition, we have Sgx SDK, TrustZone SDK. They can also be used separately to write Sgx Enclave and TrustZone TAs for other purpose. So I think when you look at our web page under the community page, a lot of projects are using our Rust SDK and also TrustZone SDK. So since Tickle is a function as service platform, users only need to consider about functions, business logic, and participants. So it's easy to invoke a function when client and user determine three factors, function, data, and participants. They can follow this step to execute the task on sensitive data in Sgx with the help of the Teaclave platform. First, just register data and function to the platform, and then create a run task. At last, you can get the Teaclave the execution result from the platform. Pretty easy. So you may wonder the internal of Teaclave platform. Here's an overview of our services in Teaclave. You can see that there are 7 kinds of services and connected with each other. And currently, services are implemented in Sgx enclaves. Specifically, authentication service and front-end service are 2 services in the front-end domain. And for core service domain, we have storage service, management service, access control service, and the scheduler service. At last, we have execution service in the backend to execute the functions, or we call it tasks. So as you can see in this picture, execution service can be deployed in different machine and connected to the scheduler service. So we can execute a lot of functions at the same time in different machines, Sgx. So the functions of different service are obvious by the name, but let me introduce them in some details. For authentication service, we just use a JSON Web Token, JWT authentication method as of a reference implementation. Also, you can replace this service as yours authentication implementations. For front-end service, it helps to authenticate request, then forward request to measurement service. It can potentially provide some load balancing from the clients. So the management service will manage function, data registration, task approval, invocation, and access controls and data persistency. So storage service, actually we implement an level DB in Sgx to store some temporary data to execute the tasks. Access control service implements an access control engine using a Python-like DSL. The scheduler service dispatches tasks to workers with desired capabilities. Probably some service execution service can only execute some Python task, and some others can execute like WebAssembly and other capabilities. So execution service is a stateless service. It's designed to be deployed in cloud infrastructure, and it is flexible, can support all kinds of Sgx runtime and other TE. The simplest thing is you can just implement the API to scheduler service and then connect it to the scheduler service with a proper attestation mechanism, and then you can use the execution service as a backend to execute the functions. So we use a tested TLS to connect between different services and define the interface are defined in protobuf, and they could communicate with our implemented RPC. So I will skip these details here and just give an overview of the interface. So in the front end and authentication service, we give the interface to clients to authenticate ID credentials. And the front end, we take requests like register data, register function. And if needed, like for multi-party compute scenario, you have to assign a data, approve a task, invoke task, and also clients can get information of functions and tasks and etc. For other service, for management service, just redirect the service to other services and do some access control. And for storage service, it will get some data from level DB. And for scheduler and execution service, we implement the subscribe and pull task model. Then execution service will execute function update status and execution result to scheduler service. And at last, the client will get the result in the end. Okay. So the code base of Teaclave function service is pretty big, but it categorizes in different directory. If you are interested in reading code, there are an overview of service and the corresponding implementations in different directory. So we have plenty of documentations to help you get started. So you can try the platform with a hello world function, and also can try to we have a tutorial to help you try to write the Python function and execute in Sgx. And we also have document to help you write built-in functions. And we have some design document like a thread model and how do we design mutual attestation and access control model and our build system and some service internals. And also we have some guidelines of some external contribution like Rust developer guideline and some development tips. So if you want to read more, here's a link. You can see the documentation. So at last, let me give you an overview of the Teaclave community. Since Teaclave is a huge project which have multiple layers, many users can get involved in the community. So platform users can use Teaclave platform directly. For example, deploy the system in their private infrastructure or to provide public service. Some users may prefer to only use one standalone service, for example, our storage service or execution service. Also, a lot of projects are using our attestation implementations. And of course, some users directly use our Sgx SDK and the TrustZone SDK to build their own applications. So Teaclave community also have already support many projects like commercial projects, academic research projects, and other open source projects. And I have a list on the community page, but it's not a complete page, complete list. If you are using Teaclave, Rust, Sgx SDK, TrustZone SDK, you can create a pull request on the GitHub to complete the list. So in this community page, you can see the organization like Baidu, Enigma, Layer X, and the projects like Advanca, Anonymous, Enigma, Crypto.com, and so on and so forth. They are using Teaclave, either the platform and the library of Rust Sgx SDK. So overall, we encourage our people in Sgx community and the confidential computing community to come and get involved. So in Baidu, we have products called Mesity, and it provides this public privacy preserving computation platform to help data confidential computing service. And also we found a recent project Safe Trace created by Enigma. Is a privacy preserving self-reporting system to do contact tracing of COVID-19. So this is a case of Sgx implement application powered by Teaclave Sgx SDK. So I will wrap up the talk and give the time to you to ask me some questions. So you can join us on the mailing list and visit our homepage and follow us at the Twitter account and check out our code and then contribute. So we call for contributions and contributors. And we announced our second public release actually this month, so you can check out at the download page. So overall, Apache Teaclave project is under the Apache Software Foundation, and we want to fully open source the project, and all the roadmap and documentations and discussions are online. And I hope people and the companies can get involved, and together we can make this project better. Okay, thank you. I'll take questions.
Thank you. So I am back. Let's wait for Felix, who normally collects the questions for us.
Yeah.
Hi.
Thank you. Great talk. So I have a question. So when you mentioned the projects using Teaclave, there were quite a few blockchain projects among these. Can you elaborate a bit on the blockchain applications that Teaclave is used for?
Actually, there are a lot of usage scenario. Basically, some will use it as a centralized, trusted service. Like for others, they may use it as a confidential, like Ethereum VM to compute the functions on the blockchain. But it depends. It really depends on how they design their blockchain or crypto applications.
I see. Yeah, that's pretty interesting. I think there's an interesting connection between blockchain and confidential computing.
Yes. So that's why our Teaclave function as service platform focuses on the confidential computing of data privacy computation, but we also separate our SDKs and execution services in a standalone service. So other people in other fields, like from blockchain, they can grab our attestation libraries or some like Python executor and port into their infrastructure to make more people use the project.
Okay.
Sounds good.
Chat.
There's another one in the chat. Quick question: do you envision Teaclave as a platform to host backend services as functions in enclaves only, or is there also a remote attestation part facing the client side? My interpretation of that question is it a backend only technology, or are clients meant to verify?
Oh yes. Actually, we designed a very interesting attestation mechanism. The client client SDK will help the user, the client user, to attest to do the remote attestation to the enclave service. For example, the front-end service, it is implemented in Sgx, and we will distribute the measurement, Sgx measurement, to the client and signed by our auditors from different parties. And the client have to grab the measurements, auditor's public key, and the signature of their endorsement to verify whether the connected front-end service is actual the service they want to connect to. So the client SDK will help you to hide all the workflow underneath. So actually, we provide the SDK in different languages like C, Rust, Python, and even Swift.
All right, that's interesting. Swift is, I think this is the first time I've heard Swift today. But
yeah, actually, we want to create an application to demonstrate the capability of Sgx. So probably will be published in later this month or next month. So that you can download the application to just feel how to use the function service on the phone.
Okay, cool. So are there, apart from blockchain, are there any other real-world applications running on Teaclave at this point?
I think there's a lot of projects are using the Teaclave, and a lot of projects I try to reach out to them and to discuss with them, but sometimes they don't open source them, or it's difficult to understand their usage scenario. So I can categorize them as two parts. One is centralize the service, another one is to make their VM confidential, just like this.
All right.
Okay, fine. Thank you, Felix. Thank you for bringing the questions to us every time. And thank you, Mingshen, for your talk.
Yeah, thank you.
It's nice. Great to have you. And